Hi, my name is Bridgette Mongeon, and I am a sculptor working on the project for Booker T. Washington. And I have with me a special guest, Tom Claus, who has been working with 3D scanning. And I've known Tom for a really long time, but Tom, I think the first time that we've seen each other since then is when I called you to come and watch the scanning of Alice in Wonderland. Is that correct?
That's right. Yep.
And it was so interesting because I didn't know you were into 3D scanning then. Now with the Alice in Wonderland project, Intertech came and scanned it. It's a monumental piece. We had registration dots all over it. It took us forever to scan all the pieces. We did two different types of scans. We did a Faro scan that scanned the whole area that we hope to make a digital representation of the area so that we can create. My goal and hope is that someday we can find a college that will do an educational, use it as an educational resource so that we can, you could click on something and find out information about, you might click on the Mad Hatter's hat and then find out that the reason why they called them mad was because they used felt, and the felting chemicals caused them to kind of go a little bonkers. We did that at night. That was a blue light scanner. So we had to do it at night, which made me really nervous because I kept thinking, what if
Right.
someone comes and robs this, us on the corner of Bel Air Boulevard.
But the resolution was good. Yeah.
Resolution was great.
Yeah.
I know scanning, 3D scanning for art, and I wrote the book, 3D Technology and Fine Art and Craft, exploring 3D printing, scanning, sculpting, and milling. So I introduce people how I use it. But tell me, for those people who are watching, especially students who are interested in getting into the career of scanning, what type of things you do in your company?
Okay. I work for an industrial pump company. Started out as a machinist, CNC programmer, and got into CAD, then 3D CAD. And they started a reverse engineering department, and which had a lot to do with scanners. Mostly touch probe scanners of the older type, and more recently, the laser scanners. So fast forward to today, I'm the engineering specialist, one of them in Flowserve for laser scanning. And in Houston here, we operate 4 different types of scanners. What we call a whole room scanner or whole park scanner, like you said, you use on your sculpture first, the Faro focus. And we also use handhelds and arm-based scanners, both touch probe and laser scanners, to reverse engineer parts, mechanical parts. So I think the way that the scanner fits into the workflow is quite similar in a lot of ways. You have a first article, your sculpture, right? And you want to capture that. When they make a new car, right, up in Detroit or wherever they're designing them now, they make them by hand, and they'll sew the seats and they'll write on there where the marks lot and sign them. And the first thing they do to try and put them into production is they'll laser scan them, and capture that image of what the artist or the designer has created. Same thing with the castings I scan and reverse engineer. I'm capturing what was originally cast, what originally came out of that mold. And the laser scanners, as you know, enable us to do that in a very efficient way, in a very thorough and complete way, so that we can use it anytime we need it later on.
So what are the type of things that you're scanning?
Impellers, molds. This is a mold, right? And see the dots all over it. And it's what will be used to cast a metal piece. And also parts, impellers like that, we'll get in there and scan with laser scanners, and also with touch probe scanners. Sometimes you have to reach inside and use a touch probe scanner where it's out of line of sight. Mostly mechanical parts,
Why don't they already have 3D models of these mechanical parts? I mean, aren't they made with 3D models or no?
Well, nowadays, more often than before, but most of our drawings are quite old. And we can make the 3D models from the old pencil line drawings, but then when some questions come up or they wonder if everybody documented everything correctly, they'll go back and scan either the pattern or the part that came from the pattern to find out what was really cast, So it's that first article, like your first sculptures or molds or whatever you create, it's that first article inspection that's really the holy grail of a product. It's what you have sculpted, it's what we have cast. And when you get that and capture that in a scan, in a new product development environment, that's the best piece of information you could have going forward. You know, when you scan that machine that passed the test on the test stand, you know exactly what you have for reference going forward.
Do you ever have an opportunity to, like, perhaps there is no part left? I mean, they can't get that part anymore, and so you have to redesign or you have to create that part because that part's not made anymore?
That's correct. Yeah, reverse engineering parts that are not documented or not made anymore. But it's either, you know, scan the physical sample and it might have holes in it or something, and, you know, rebuild it from that, or make it from the drawings. Otherwise, it's just designed from engineering data, which is kind of another subject.
What does reverse engineering mean?
Reverse engineering is measuring a part, laser scanning it, and breaking it down, its features down, design it again in CAD like the original designer did. So instead of making it, engineering it from calculations and drawings, it's designing it from a sample that's scanned or measured.
So when you started out, I mean, I'm sure 3D scanning is fairly, well, it's been around a while, but it's fairly new as a career. So you kind of like fell into it. So how would somebody, a student who is wanting to get into this practice and this job, how would they do that? What would they need to study?
Well, to be a 3D scanning technician per se, I would say that's maybe a 2-year degree, you know, 2-year college degree, or even a high school with some technical courses, right? That might be one career. To get into the engineering end of it, where you perform the calculations and analyze or design what you've scanned, is kind of 2 different careers. To get into it, you could get out of high school at an entry level. You could get out of high school and hire in as an assistant. The people that were down scanning your statue were helping to put the polka dots on. You know, they're learning as they go, right?
Right.
And right. And so, and I'm thinking more mechanical fields. You might get a job as an inspector or a warehouse person, and they need to document some parts, and you learn how to laser scan them. Operating the scanners can be fairly simple for some of them. So, and, you know, the next level would be to learn CAD, to learn 3D CAD, you know, and understand it well. That doesn't necessarily require a 4-year college degree either, you know. So a couple of CAD courses, maybe a couple of certificate courses at a community college. And then, I mean, the trick is to find somebody that has the scanners and it needs the help. So
do you think that it's a growing field?
it is a growing field. And the photos I showed you of the flying Faro Focus scanner, they have a drone that it's mounted to now. So especially in the area of you know, terrestrial and the Google Map type of scanning, I mean, it's everywhere. The automated vehicles that are going to drive themselves use scanning technology. So when you say scanning, I guess you mean, you know, this object scanning and fitting it into either an artistic environment or an industrial environment. Yes, I see the field growing for sure.
I think it also that it's exciting because it does overlap so many. I mean, there's geology, there's mechanics, there's science and medicine. There's all these different fields. So depending on what area interests you, you can actually work with 3D scanning in that area, which I think is fascinating.
Yes, it is. It is. Yeah. So if you have an interest in a particular area and an interest in the technology, you can do them both.
What is the now you talked about this scanner that was attached to a drone. I think that's fascinating because you get to play all day and fly a drone, but I'm sure you know, crashing that thing, you got to really practice flying.
It was, yeah, I mean, it's about what, a $50,000 scanner, and the drone was a couple $100,000. That was the first flight at Sam Houston Race Park. They flew it around and scanned the park there. It was very, very interesting. Those are used to supplement ground-based scans. So, for example, if they wanted a scan of the whole park, Evelyn's Park, right? You scanned it with a Faro Focus, you got your sculpture. If they needed the tops of the buildings and the adjacent streets, then we might come in with a drone and do that. But that's just taking off, if you will. That was a first flight on that scanner. I think it was about 1.5 years ago. So,
well, let's talk about the project that I'm working on and that we are working on together, which is fascinating. Now, originally I was contacted by Booker T. Washington to do a sculpture, and they really liked the sculpture that was at Tuskegee. And they said they wanted me to copy that. Well, if you know anything about copyright, you can't copy a sculpture. You can't, same thing with 3D scanning, which is really important to know. If you have a 3D scanner, you can't just scan anything. It would be an infringement of copyright. And
Right.
so I told the client that I couldn't do the job. I wouldn't, plus, you know, what fun is it for me to sculpt, to try to copy someone else's sculpture? That's no fun for me as an artist. But I said that we might be able to 3D scan it. And if we went in and we 3D scanned it, then we could reduce it down. And from my experience in doing this as an artist, I know that when you're doing this, if you go from big to small, which I've seen with Alice, it doesn't all, the details don't translate. There are problems going small to big, and there are problems going big to
Right.
small. And so you would have to modify that sculpture a bit within the computer for it to come out at the size that it needs and to translate correctly. For example, with Alice in Wonderland, we had her, they had 3D printed a little bit of her shoulders. And we noticed that some of the ruffles in her shoulders wouldn't translate. They were just too thin. They wouldn't be able to print it. And the texture that was so, I'm known for my texture, was missing. So I had to beef up all that texture because when it came down, it disappeared. We were originally going to scan it, but the school decided to go in another direction. And they decided to do the traditional pose of Booker T in a chair with his book reading. And so I had to come up with a design. I found an original chair from that time period, and I sculpted it small. I made a little tiny replica of that. And then I also sculpted Booker T small so that we would have a small, what we call a maquette of what we are going to try to do large. And even that, even hand sculpting small, what you're trying to do small does not look the same as big because,
Right.
you know, I mean, it's teeny tiny. So I had that done in clay, and then I had to have it scanned. And that's where you came in. Now, the reason why I would have to have it scanned is that I will take that clay maquette, will scan it, and then I can send it to a company that CNCs, or computer numerically controlled, mills that out. So there's data that's collected by the scan that the CNC machine can use to then, they carve it out of urethane foam for me.
Right.
And they make it really large and they send me these pieces, and then that becomes my armature. So in the case of the Booker T that we're doing, he's going to be 1.5 times the size sitting in a chair in front of the school. So we needed to have, I need to have an armature. And by hiring you to do this, and by doing the CNC milling, it saves me months of time and lots of physical labor. In the past, what artists would do is they would take the little sculpture and they would look at it and they would measure it. Then they'd go over here and they'd build this metal armature with welding. And then they would put, they would wrap it with chicken wire, and then they would smash clay.
Right.
And it was so time consuming. So this has saved, this process, which I have adopted, has saved me a lot of time. And so I invited you to come in, and it was really great because you had somebody with you, a young man that was also wanting to learn. So in that, you taught us a lot in that thing. So let me, can you, in that little episode, first of all, we scanned the chair. Let's talk about the chair. And the reason why I wanted you to scan the original chair, the chair from that time period, was that I was not sure that the translation of the chair that I have was perfect. Like you say, I guess that would be reverse engineering, but tiny. Was it actually, and there was like concaves on the back of the chair, which was just too hard for us to do with our pieces of wood. So we modified the chair small, but I wanted it as close to real as possible, large. So talk to me through the process, and I'll share some of those photographs as you're talking about what you did with the chair.
Right. Yeah. So I brought Lex with me, and actually, he's the one you hired to do the scanning. He's the one that's getting paid. So he's a freshman engineering student. We did scan the life-size chair and the small sculptor, sculpting that you did, we used the same instrument on it, which was a Handy Scan 700. This thing here, and you've got photos of that, right? And photos of us scanning it.
And the maker of that scanner is
Creaform out of Quebec. Yep, made in Canada. So an excellent instrument. They just released a new version of that at half the price of what it was a few years ago. Interesting how the hardware is coming down. Yeah, and that's an excellent instrument. Lightweight, too, very ergonomic.
So what does that scanner cost, out of curiosity?
The newest version of this, I just got the release on it, is list price is $20,000 for the whole rig.
Oh, that used to be
expensive.
40.
It's expensive. It used to be 40, right? Yeah, it's come. I think those rough numbers. So, very good scanner. It's not just the hardware. Sorry to get off on a tangent. It's not just the hardware performance, but it's the job that the scanner and the software does of creating an STL as you go. And it does it very accurately and very well. So that can save you a lot of time later on. So we used the Handy Scan 700 on both those scans. The process was pretty straightforward. We stuck a bunch of targets on there and used the handheld scanner and created an STL file that we handed off to you. We had to do some post-processing on that work. But my observation with that was it was quite easy for Alexander to do that work. I simply showed him how the scanner operated, how to apply the targets, how to use it. And then I took him home and he did the post-processing work on the few smaller pieces we sent you earlier, which included cleaning up the STL and reducing its file size, right? Filling some holes, preparing it for handoff. So he jumped into a very specialized software and was able to use it after just a few hours of instruction. He certainly enjoyed that. Yep.
So let me go back because I want to reiterate and I want to talk about the details of what you've done. You put targets on the sculpture just like we did with Alice in Wonderland. And those are little targets that we see on that piece back there. And basically the scanner is looking at those targets and using it to register, correct?
That's right. That's right. The neat thing about that is, you know, some scanners you have to fix the part and the scanner has to be bolted down to a table, if you will. You know, once you get these targets on your part, I could be scanning this part and you know, with the scanner in one hand, the part in the other hand, it could be floating, you know, moving around in space, no problem. Those targets lock the scanner on, you know, just like a missile coming out of a jet, I guess. It's going to stay focused on that piece. That's the amazing part of it for me. The hardware software can return that amount of accuracy without the parts being fixed. So the targets align the scanner to the part and it puts down a grid of laser stripes. It measures the time of flight that laser takes to hit the part and to reflect back into the scanner, and it creates a 3D point cloud. And from that point cloud, it creates an STL mesh, which is what the final result is, STL file.
So a 3D point cloud is just, when you see it, it's all these little teeny tiny points.
That's
and
right.
STL file is the generic file that most scanners and 3D printer companies, et cetera, use, an STL.
That's true. An STL is a mesh, which is just a bunch of triangles connected between those points. So it appears more like a surface. Although really large scans, like the one you have of the whole park, or one you may have of a whole bridge that somebody's building, those scans are so large that they are easier to process and use as a point cloud. And the software is getting better and better at that. Some of the really large scans I've done, I never really took them into an STL. So there are ways to interrogate a point cloud, you know, get sections out of it and fit planes and cylinders and surfaces to it without ever going to a mesh. But most of the time, as you said, it's a mesh that's created from a point cloud, and that's, you could say, typically what's used.
Now, I'm also going to backtrack because I remember when we were at the park and there was a railroad track down from the park and the train went and the scanner people stopped because they said that the vibrations of the train felt through the sculpture could be picked up in the scan. Are they really that sensitive?
Yeah, so that scanner, yes. That scanner is similar to a white light scanner. You had to operate it at night. You know, it can't have a lot of ambient light. They are typically more accurate. The targets are smaller than the ones I have. So the vibration could affect it. I'm a little surprised because it is a tracking scanner. It has those polka dots, if you will, those targets to keep it locked onto the piece. I think what they were afraid of was some sort of vibration in their equipment. That scanner was hanging out on an arm, I think, and they might have been afraid of it just vibrating a little bit, and vibration within the camera itself, especially a small vibration like that, might affect it.
So you were talking about the 3D point file and the STL file. We talked about a point cloud, and we talked about triangles. Now, the difficulty for me, there's two things that happen when I have things 3D scanned. One is the scanner creates so much data that it's more data than I need.
Yep.
And so what might be what an engineering firm might need, or somebody else might need to collect all that, but it's way more than I need, or that I can use, or that my programs will use. Right. So that's one problem. I have to decimate that file, or I have to find my company that sends it to me, or I have to decimate that file to be able to get it into a workable file. The second thing is that when you are doing, unlike your engineering software, the software that I use to sculpt in only works with quads and not triangles. So here is a geometry lesson. So right. You send me a scan that's all in triangles. If I try to sculpt on a scan that all has triangles, I have artifacts. There's a wonderful video on what an artifact means. And the only way I could describe it, traditionally, it's almost as if there is a big piece of grit in the clay, and every time I try to go over it and smooth it, it just destroys that area. So I can't get what I want. So you have to create this in quads. When I wrote my first book on digital sculpting with Mudbox, the going from triangles to quads was like the holy grail. Nobody was doing it back there, but it was the holy grail. So you actually, as an artist, had to take your 3D file and you had to do edge loops going all the way around, and then you had to make your quads individually. You had to retopologize it physically. And so in the Mudbox book, I had something scanned and we brought it down and it didn't work, and there was no magic button to do it back then. Now there's magic buttons. And my partner decided that he would retopologize it. And so he retopologized this little sculpture of this mom and the baby, and it had my copyright notice on it. And he said, but it's not yours anymore, it's mine. I retopologized it. I said, no. No. Just because you retopologize something doesn't mean that you own it. It's still my image. So retopology has come a long way. And I could go on and have a whole program about copyright, infringement, and 3D scanning, and all that it entails. But so I had to do that, and I do still have to make it into quads. Luckily, in the programs that I work with, which is Zbrush and Mudbox, you can press a button and it will retopologize it for you so that you can work on it easily. Some of the retopology is not as good as others, but it does it, and you don't have to physically retopologize it. So when you talk about what the scan is coming, can you kind of educate us how detailed those scans are, and how you relate that to human day-to-day terms and we could understand?
The resolution is always a big deal. I mean, some of the scans I get now are as large as 2 gigabytes in size when I process them. The Dell workstations we use now work quite well on that data set, as long as you reduce the file size soon. And you typically do that before you start working on it in any way. So it either starts out as a super huge point cloud file or a super huge STL, and then you got to work on it. Now, I'm not familiar with quads, but I think I know what you're talking about, because when you start 3D CAD and you loft your first surface, you get into UV lines, that grid. And it's always little squares and rectangles that work most efficiently, right? Well, an STL is a bunch of triangles. And the problem with those triangles is when the angles on them get really small like this and turn into little slivers. I think that's why your programs want it to go to quads to reduce most or all of that. Because as you would try to manipulate that or reshape that, it's going to react much better than triangles would. But the STL is quite efficient and it works quite well. What comes out of this scanner I have is excellent. And again, it goes back to my statement about how well that scanner software and hardware does at creating what I'm going to call a clean STL, because there's a trick to that, you know. STLs are pretty dumb files. There's not much you can do with them. You can section through them. You can use them in 1,000 ways downstream, right? But it is what it is. It's a bunch of points with triangles laid over it. So it's in regards to detail and file size, most of the files, even on large industrial pieces we scan, the files and the STLs we upload are usually less than 30 megabytes. And that involves taking a file that's half a gigabyte, getting what you need, cleaning it up, and turning the resolution down to an acceptable level. Now, there's ways to keep the resolution real loose on flat surfaces, but in corners, you know, you'll have a higher resolution of triangles or points. So the software is quite efficient at doing that.
When you say, when I look at that scanner and I say, well, how detailed does it go? The company will say it is such and such resolution.
Right.
Right. So when we look at the scanner behind you, the Creaform,
yep.
What is the resolution in that scanner? Do you know?
Yeah, this one, the newest version they got out now is 1/1000th of an inch, 0.001 of an inch, which is very fine. You know, what's a human hair? 2 or 3 thousandths? I don't know. That's the best it can do on a non-reflective part, right? But if you're not going to keep that amount of resolution, I mean, you're going to scan the part and the software is going to create a higher resolution on curved surfaces, you know, around corners and things like that. But on flat surfaces, there's only going to be, you know, 4 or 5 triangles on that plane. So that's logical and for downstream use. So it starts out very large file size, but becomes reduced. Resolution, it just depends on the project at hand. And you described some really challenging things with resolution. It become from scaling large to small and small to large.
I know that when I've tried to scan things before, there are certain conditions that are not good for scanning. One, which you just said, was a reflective surface. Right. And with reflective surface, those often need to be painted or powdered or something of that nature.
Yep.
Although if it's fine art, we don't want to do that. We don't want to injure the art in any way. And so, but it is, if it has a mirror or high gloss, that the scanner can't get it as well. And so that is one problem. Is there other problems?
Anything that's opaque is a big problem. With the light can go through it, and it doesn't know exactly where to reflect off of, there's big trouble. That scanner does really well on dark and reflective surfaces, although you're absolutely right. Reflective surfaces are nothing but problematic.
The chair, you put the registration marks on it, and you were able to scan it with that scanner, and you were able to tip it upside down. So you were able actually to move. That thing didn't have to stay stationary,
exactly.
But the points on it had to stay stationary.
That's right.
Those points are. So then you could move it upside down, and because it had a really great bottom to it, then you could do the points on the bottom, put all those things on, as long as you could capture some of the points that were at the top, then, or on the under or the top side, then the whole thing could be registered.
It's all registered, and there's no subsequent having to best fit or align those scans together. That can be real efficient, and it can also be problematic depending on the type of data set that you have. But you're right. We put the targets on the chair. We turned it over. We added some additional targets. You have to have that overlapping area to scan, or the overlapping targets as you turn a part over. The most challenging would be something that's disc shaped or like a plate, you know. But there's a lot of workarounds to that. You can set targets on your table, scan it, flip it over, and then remove the table targets. There's a lot of little tricks to doing it. That's where the handheld scanners are really handy and easy to use. And it's fast, because all that subsequent, you know, having to register scans and everything, what you get is just one scan of the part, and it's high quality. Yeah.
And you use the same scanner, I believe, as we had the small maquette. Now I have a little tiny Booker T on the made up chair that we made. So I needed you to do two things for me. One, I needed to know how Booker T related to that chair. So I asked you to do a general scan so I could see his relationship to the chair. Then I cut him off so I could have just a scan of Booker T. Now, the reason for that was because that will then be enlarged, and it will go on this scan of this original chair. I'll actually do all that in the computer prior to sending it to my company, but to my CNC people. But the reason why I needed that was because there's a really good chance that when I get the digital model of Booker T, he won't look natural on the chair that you scanned, because he wasn't created for that chair. He was created for a little maquette chair. So in the computer, I will merge those two together, refine that, do any modifications that I need to make sure that it works when I get these files from you. So I'll have a chair file, I'll have a Booker T file, and I'll have a Booker T with the chair, the smaller made up chair file. And I'll kind of be looking at these together to get them all ready. And I am just chomping at the bit to get those files because I can't wait to get to this next part.
Really, really challenging workflow because of its art, and you can't go back to CAD with it, Something similar in regards to workflow we would have mechanically is that I just quoted a scan down in Brazil. You have a huge water pump down in the hole somewhere. It's huge, like as big as maybe your living room, the room it's in. And they want to scan it, but it's assembled. So I told them, let's scan it with the pump and the part that comes out and the shaft and the motor's way up in the air. So they're, scan the whole thing together. Then when you take it apart and scan the insides, we know how to register them. So another challenge, not similar exactly to yours, but in the mechanical world, there's a lot of forethought that needs to go into a scan. I think is one important mention. How are you going to assemble them later? What are you going to do downstream with the data? And especially in my business, the best thing to do is talk to the person that you're going to be giving the data to in the end. Often that's not the person telling you to go to work. And, the person that's going to use that, your vendors, I guess, mine would be the internal engineers, and understand what they need in regards to what type of data, what sort of format. But yeah, the registration is tricky. To try to do it artistically like that just kind of blows my mind. I'm going to leave that one with you.
Well, it's interesting because when you have a sculpture that you are trying to scan, one of the problems that happens with the scanning company is undercuts or deep areas. So for example, with this, you need to be able to get the scanner needs to be able to get in there, or it needs to be able to see this.
Yep.
So in the case of, or even inside his mouth.
Yep.
Inside his mouth.
Yep.
So with those type of things, this is a 3D print that's not as detailed. With those type of things, it's really important to, we call them undercuts, so that the scanner can get in there. A lot of times, if there's deep undercuts, we will actually might have to cut off the arm.
Yep.
So the scanner can get in there, and the scanner can get all the way around the arm and behind the back. That's why we actually took him off his chair and we set him on a teacup when you were scanning him, so that we could get all around the backside, all underneath his legs. When I'm going to CNC for foam, that doesn't matter, because I'm just looking for a basic armature.
Right. Yep.
And just like anything else, the more time on a machine, the more money. So if I wanted to get great detail on a CNC machine, which is not really, it's just not a reason to do it.
Right. That would be costly.
Yeah.
Yep.
It would be very, very costly, because I would have to pay more money. It would be more time on the machine. They might have to have a robotic arm that has runs on more axis, change the bits so that you can get smaller and smaller, all sorts of things.
Yeah.
So, and that's also the interesting fact, is that when I have this thing CNC milled, which is computer numerically controlled milled, the CNC company will ask me a couple things. How do I want it broken up? They may decide to cut it in certain ways. For example, I did a monumental sculpture of Eve. She was 15 foot tall on a splash. They cut her right at below her knees. they cut her arms off. So, and then I can attach them. They have a metal armature in there. So I can attach those things. I can work on them separately, etc. But they didn't cut her off her head. And heads are everything. Off with their heads. Alice in Wonderland. So if I could always have the head that's separated, that will be great. Now with Booker T, the CNC company said those slats in the chair are so thin that if we try to CNC mill them, they're a good chance they're going to break. So you might want us to CNC mill part of his back to the chair to give that some more strength. So my brain is thinking about these scans and how they're going to cut them up, because I want to be able to work on them the best way that I can in the studio, make it easy for my people. Booker T will be taken off the chair and worked on. He was on a teacup in the studio. He'll probably be on a base just the right size so that we can get around his legs, etc. He'll be on one pedestal and we'll be working on him, and somebody else in the interns will be helping me on the chair. And then because the foam is so light, you could just and set them on. The difficulty with that is, which we had when we cut him off, was that his suit coat goes over the chair. So if you don't cut it so you can get him off of it.
Yeah, and you can get some movement after cutting. Yep.
Get him in there, then that's difficult. So that's a little bit about my process and what we're doing. Now, when you say post-processing, you've done the scan. Talk to the audience about what you're looking for in post-processing and what you're fixing.
Yeah, well, most of the softwares now have wizards for that, that try to put everything into one dialog box. So you go into the mesh cleanup wizard and it'll address a multitude of problems with the STL, which can be self-intersecting triangles, and spikes, real sharp triangles sticking up from noise. There's also smoothing. And in general, it looks at the STL and cleans it up and eliminates some of those problematic, some of that problematic geometry that'll give you trouble later in your mesh software, or your quad software, which you called it. Yeah. So cleaning it up is it can be is fairly easy once you learn how. But you can start out. I can start out with something mechanical and quite prismatic, and I trained a guy once. He scanned one of these impellers, and he said, "Well, I cleaned it up in the software, and it came back looking kind of like a potato." And I'm like, "Well, you got carried away with the smoothing stuff, So, in my world, there's limits to what you should do with it. But most of the software, after you learn it, is quite easy to use. It is.
That's when I just wrote what you should do with it, because when it's fine art. And I've had the foundries say this to me too, when there's fine art and they're trying to reproduce. So after I'm done with my sculpting and the clay and the client approves it, it'll go to the foundry and they have to make a rubber mold of it. And then they have to make a wax of it. And then it goes to bronze. But in that process, you've got people's hands working on it. And if somebody decides to smooth something that I didn't want smooth, they're actually changing the art. So having this, what you should do with it, comment is really important for fine artists that are working with this. I know that with post-processing, when the file comes to me, and I've worked on it in ZBrush and Mudbox, and there are other programs, Blender and other programs, and there's a free program that's Blender, and there's a free program that ZBrush uses. You can go on their website, Pixelogic website, and get it. But when I work on these programs, when I've got done with the sculpture, so before I can go have this file 3D printed or CNC milled, I have to put it through a check myself to check for reverse normals and all sorts of things. And so there are free programs that do that. MeshLab and Mesh Mixer are free programs that I can send this through and it'll tell me all the different problems with the file. So a lot of people think that you can, like, 3D printing is real easy. I'll just go and press the button. It's not that easy.
No. Yep.
There's a lot of work that needs to be done with that.
Very true. Yep.
Anything else that you need to share in this process?
Trying to think about what I could share with your students. We talked about, hopefully there's a few of them that found interest in this and want to do it for a career. I guess the thing I could share is I have found it quite rewarding for my career. It's been a special niche here at my company that I've thoroughly enjoyed filling. So want to throw that plug in there. The best thing I like about it is it puts me right in the middle of the latest technology, right? You know, the latest software, which is really cool. Now I'm talking out of the educational environment, you know, out in the workplace, the latest software, and so, you know, it's quite interesting. It's not. I mean, everybody that comes by, I had one guy come by my office once and look at what I was doing on the computer. He goes, you know, you got the coolest job at at the company, man. He goes, I wish I had your job. And God bless him. He's a manager and he's good at it. You know, we need him too, but I wouldn't want his job. I love what I do, and I'd like to just throw that in there. On the technical side of it, you know, I think we did a good overview and covered a lot of things on scanning. One last note on the mechanical end, the world I work in, our scans are usually just a reference. They're not art like you have. You know, everything we create downstream is a CAD file. We're going to reference that scan and we're going to create a parametric CAD file out of it. I've done a couple of hybrid models which involve a scan and CAD merged together, but that's a whole nother strange world that's quite problematic. So whereas you're typically working off of that scan as an STL, I don't think you ever go to a NURBS CAD service with it. It's usually an STL or a quad mesh form, and it stays as art. It doesn't get reverse engineered.
So let me also ask you about when you buy a scanner, the $40,000 scanner or whatever you're using, does the software come with it, or do you have to buy separate software to get it going?
Good question. This scanner, I believe the software travels with it, at least the basic operating software. Yeah. Guy I used to work with here at this company is out on his own out in Spring now. He bought himself a scanner and is doing contract work. And he got his on eBay. So I'm quoting you list price on these things. They are available. There's a lot of companies that get scanners and really go out and buy equipment and software that don't fit the bill for what they really needed. You know, they like to sell this stuff. So it happens quite often. So if you're ever interested in it, you can usually interested enough, you can usually get into it. Yep.
And we did talk about, if anybody's listening and they could note, we talked about laser scanner. We talked about white light. We talked about blue light. So we are talking about, when we say 3D scanning, it's not just one type of scanning. Another element that we could talk about is photogrammetry, which is basically taking photographs and overlaying them and getting the information from them. And so you have to be versed in whatever the company that you're working with, the scanner and the system that they're using. Right. Do you use all of these type of scanning? Which ones do you use?
I used most of the scanning types except the structured light, which is like that white light scanner or blue light scanner they used on Alice, your Alice sculpture in the evening. I used most of those scanners, including what I call the whole room scanner, the Ferro Focus. That's a LiDAR scanner, and it is a radar kind of base scanner. It uses a laser, but I think it's infrared, so you don't actually see it. You know, it's not quite as accurate as the light scanners.
The other thing that I want to point out is we had talked about there's so many different ways that this is being used. One way that I want to just mention, which is really important to my heart, is digital preservation as far as artwork goes. And so the digital preservation, I mentioned this in my book, it's really important because things like the pyramids or things that they dig up, they are by nature deteriorating. So if they can capture these details as digital files, then we have that preserved forever in a way that just having the artifact in a museum, as I said, it deteriorates. So a lot of the museums, you can go to the Smithsonian, et cetera, and they're starting to actually 3D scan all of their artwork. And therefore, then you could take the model, you can go to their site, you can take it, you can turn the bust of Lincoln around and see his whole face and see every direction. And that just is really fascinating. Now, I did talk about in the book how it happens a lot during war. It happens a lot during, unfortunately, religious differences. that people destroy artwork.
Right.
And so once it's gone, it's gone. And
Yep.
that's a person's, that may be a people's culture that is gone. So there is a company called SciArc, and they have a lot of information. They work with scanning companies that volunteer all over the world. And they take, so for example, your company, if you were one of the volunteers, might be commissioned to go and scan Mount Rushmore.
Mhm.
And then you would scan Mount Rushmore, and that data would always be there. So if there's an earthquake or whatever, and that thing goes down, we have the digital data for Mount Rushmore, or the Eiffel Tower, or
Yep.
whatever. And so these are really important, but SciArc has a lot of educational tools on their website for instructors, for students, et cetera, that they can start to understand and get to know 3D technology, and especially as it pertains to art preservation and 3D scanning. So I would highly recommend them.
Very interesting. I'm glad you brought all that up. I would be so surprised. I mean, anybody digging into a cave, if the first thing they didn't do is sit a scanner down, a whole room scanner down, and scan the cave before anybody else came in, I would be really surprised. Getting things in an undisturbed way like that, even if it's just a reference, is so important. And one other quick thing, before we finish, in all the training, I've seen a lot of people that use scanners in a lot of different ways. Guys from NASA that scan the windshields of the space shuttles as they come back in and map out all the little imperfections in the glass from the space garbage they hit. I mean, that's their job. He says, don't anybody tell you they can't scan glass, because we developed our own scanner to do it, So a lot of really interesting ways. And that whole room scanner, again, the one you used on Alice, that got the whole park, is used regularly in accident investigation. There's police that got those things. They'll just stick them on the back hood of their cruiser, and they'll spin them up and scan, these serious accident scenes with it. And also for forensics, I was in a Faro class for that scanner once, and the lady sitting next to me, believe it or not, worked for NCIS. And, she looked like she could have been on TV too. I'm like, oh, I didn't think they'd all look like that. Very nice person. Part of that class was, putting the bodies up there with the little things coming out of them where the bullets might have hit them. That was her interest in scanning. It's used everywhere. It's just used everywhere.
Well, I'm sure a murder scene, if you can go in and you can scan
Yep.
the whole murder scene, you have the details before anybody touches it.
It's used a lot, yeah, in forensics, yes.
So it's just a fascinating, fascinating thing. Well, I am really excited. I'm glad that you're going to be a part of this educational process. Booker T. Washington is trying to raise the funds to create this sculpture. So as soon as I get some more money, I get to send you money, and I get my 3D scan, and then we can move on to it, because that's my really exciting process, is actually getting in there and getting it big. And so you can watch this at the Booker T. Washington website and the blog post, and I'll put the links below. And I'm so glad that you've been a part of this as an educational feature for students in science, technology, engineering, art, and math, because STEAM education is so important. And I think that you've really given them something to think about. Thank you.
Thank you, Bridgette. I'm glad you invited me.
Okay, what's your company that did all this? This is so great that they were part of it.
Flowserve is a company I work for. Yeah, we use the scanners and regularly. Yep, most of the major pump companies have all this technology and everything I've shown you. So it's nothing that proprietary about it. You see, it's a very commercially available today. Yep.
Thank you so much. I appreciate it. And we'll have to get together when this sculpture is done and go, okay, we did this, and bring Lex along. So that
I will. Yeah. Okay. Sounds good.
All right.